What's up, bitches? In this video, we're learning the initial value problem chapter for your differential equations class. Basically, what this chapter says is you have an equation of x, and when you integrate it, you're going to get f of x plus a constant, right? That's what happens when you integrate. When you integrate this again, you're going to get some equation of x plus c1 times x plus c2. When you integrate it again, you're going to get a third constant, whatever. What this chapter covers is they're going to give you these random values at x of 0. I don't know. It doesn't matter. 1. X prime of 0 equals, I don't know, 2. It doesn't matter. Basically, using these initial values, you have to plug into these equations and find C1 and C2. Your whole goal is to find these constants to find the actual equation, and that's it. So this is a typical problem that you're going to get. They're going to give you like an equation over here. They're going to give you your initial values, and they're going to tell you to find the constants, C1 and C2, okay? So the first step that you do to solve a problem like this is you have to find all of the derivatives, okay? Here the max, we already have x here, so you don't need to do anything. Next, we need to find x prime, okay? So you just have to derive this. This is literally just cal 1, okay? So this becomes negative c1 sine of t. Then this becomes plus c2 cos of t. Okay, that's x prime. So now let's begin. Setting x prime at t equals 0 equals 8 is negative c1 sine of 0 plus c2 times cos of 0. All right. Sine of 0 is just equal to 0, so this cancels out, and cos of 0 is equal to 1. So 8 equals C2. All right, you found your first constant. Next, you're going to plug in this equation over here. X of 0 equals negative 1 equals, we're just going to use this equation over here. C1 times cos of 0 plus C2, which we found to be 8, times sine of 0. Sine of 0 is equal to 0, so this doesn't matter. And cos of 0 is equal to 1. So negative 1 equals C1 times 1. C1 equals negative 1. So your full equation becomes x equals negative cos of t plus C2, which is 8 sine of t. That's it. Super easy. Okay, last example, it was super easy. Now I'm going to do an example like this, which is a little bit harder. But it's the same steps, literally. Here it says y prime. So you have to find the derivative of y. So here it's c1 e of x, then negative c2 e of negative x. That's it, okay? Now, y prime of 0 equals 2 equals c1 e of 0 negative c2 e of negative 0. E of 0, it's equal to 1, okay? So this doesn't matter. So 2 equals c1 negative c2. You don't have a complete solution like we did last time. That's why it's a little bit harder. But don't worry about it. It's still easy. You just send c2 to the other side. c1 equals 2 plus c2. Next, we use this equation over here. Y of 0 equals 1 equals, and we just plug in all the numbers over here. c1 e of 0 plus c2 e of negative 0. So the zeros, they're equal to 1, so it doesn't matter. C1, we're going to replace it with this, and we're just going to find the rest of the value. 2 plus C2 plus C2. 1. Actually, I'm going to send 2 to the other side, so that this becomes negative 1 equals 2 C2. C2 equals negative 1 over 2. And we know that C1 is equal to C2 plus 2. So that becomes 3, 2. So now the full equation becomes 3, 2 e of x, negative 1 over 2 e of negative x. That's it. Super easy. There's nothing complicated. Even if you don't understand, bro, like they're literally giving you anything. You just plug in all the values and you just do algebra. Very easy. So this is the last type of question that they're going to ask you for this chapter. They're going to give you a differential equation and they're going to ask you to find the region where there's a unique solution. What that means is you take your normal equation and you have to isolate the derivative of it, okay? dy or over dx or whatever. And then you have to consider this as a separate function, like dependent of x and y. Then you have to do the derivative of that. And then you have to check the continuity of this derivative, okay? Continuity. Now, if you guys don't remember, continuity is just a fancy way of saying where you could draw the function without lifting your pen, okay? So something like this, it's continuous, okay? It's discontinuous if there's something like this, like gaps, or if there's a sudden change in your function like this, okay? The way you do that is there's three things you have to look out for, okay? The first are fractions, where you have your numerator and your denominator. The denominator cannot be 0. Otherwise, it doesn't exist and it's discontinuous. The second thing are square roots. Whatever's in the square root, it can't be less than 0. It can't be a negative number. It can be 0, it still makes sense, but anything below 0, it doesn't make sense. The last thing that you have to check are lns and logarithms, okay? Unless if it's ln absolute value of x, then it doesn't matter. But if it's just normal lns, it can't be 0 and it can't be less than 0. So it has to be larger than 0. If all of these are the three things you have to look for. If all of these are okay, then it's continuous, okay? So let's solve this problem. For our problem over here, step 1, we already have the derivative of y, okay? So we consider f of x, y as this, okay? Now we have to find the derivative of this with respect to y, okay? So this just becomes 2, 3, y. And 2/3 -1 is -1/3, okay? That's basically 2 times 3 cube of y, okay? Now, this is not square root of y, so it can be negative, okay? Like, it doesn't matter, okay? If it's square cube of y, it could still be 0, it still makes sense. If this number over here is pair, then you have to look out for this rule over here. But that's fine. The problem here is the denominator over here. Since we have a denominator, this whole part over here cannot be 0. And the only way this part would be 0 is if y is 0. So y cannot be 0. So for this problem, you would say it's unique. There's a unique solution everywhere. Unique, except where y is 0. That's it. That's the way you solve it. If you don't understand this part over here, it's just a bunch of like fucking theorems that they're proving it with. These are the steps that you have to follow. You don't need to learn any of that shit by heart, okay? You find you separate the derivative of y, find the derivative of that, and you check the continuity. And it's unique everywhere except where it's discontinuous over there. And that's it.